Did you know that the existence of a planet beyond our familiar reach, located just 4 light-years from Earth, has long been a prime target for those searching for extraterrestrial life? That planet is Proxima Centauri B. It lies within the habitable zone of the Alpha Centauri star system. But could we actually live there? The challenges humanity would face are not limited to engineering or science alone, but to a constant struggle against forces from the universe that we cannot fully predict. We are confronted with the most fundamental philosophical questions about life and existence. If a planet like Proxima Centauri B could serve as a cradle for new life, could we adapt to conditions entirely unlike those on Earth? It is a place we never believed we could reach. And yet it is where we begin our journey into the harsh reality of Proxima Centauri B. Proxima Centauri B, a jewel nestled within the Alpha Centauri star system, is a destination for boundless aspirations, but it is also fraught with unforeseen dangers. The Alpha Centauri system, with its 3 stars weaving a cosmic tapestry that never sleeps, is anchored by Proxima Centauri, a red dwarf star. Small, yet astonishingly long-lived, that serves as the host star of this distant planet. Unlike our brilliant sun, Proxima Centauri is dimmer. But it possesses a strange and remarkable trait: its ability to sustain life over an extended period, even long after our own sun has burned out. The only planet within the habitable zone of this red dwarf might represent humanity's next great leap. That lies within the habitable zone, the region where liquid water could exist. A key factor that makes Proxima Centauri B a promising candidate for extraterrestrial life. But does this truly translate to the possibility of human survival? Is this the paradise we seek, or is it merely a lifeless world shattered like a distant, unreachable glass pane? Proxima Centauri is a red dwarf star, cooler and smaller than our sun. Yet it boasts a lifespan hundreds of times longer. This means that if Proxima Centauri B truly can support life, it could maintain a stable environment for millions of years, outlasting the harshness of younger stars. So, can life thrive here long-term? Or will our existence be but fleeting moments in an infinite universe? Imagine stepping foot on a planet beyond Earth, where the concepts of life and death are no longer what you've known. Can humanity survive here, in a world where familiar conditions like energy and atmosphere no longer hold the same meaning? Proxima Centauri, the host star of this planet, emits only 0.1% of the light our sun provides. Though it seems faint to us, this light is the lifeline for Proxima Centauri B. To survive, this planet must orbit perilously close to its star. As if caught in an irresistible dance with an unstoppable force. But what no one expects is that this close proximity doesn't just provide the energy the planet needs. It also introduces a deadly environment filled with hazardous radiation. The radiation bursts from the red dwarf, unpredictable energy discharges, could strip the planet's atmosphere away, dismantling the fragile foundations of life. Imagine a planet with no protective layer strong enough to shield against ultraviolet rays and continuous radiation blasts from the red star. It's the cruel irony of the universe. A planet that has the potential to support life could be the very place where that life is most easily lost. And what about the atmosphere of Proxima Centauri B? Is it even breathable? The answer serves as a cautionary tale. The planet's atmosphere is thin, containing very little carbon dioxide, methane, and nitrogen, essential components for sustaining life as we know it. Its atmosphere is not only fragile, but also incapable of trapping enough heat, causing the planet's temperatures to swing drastically. From minus 40 degrees Celsius to 30 degrees Celsius, humans would face skin-piercing cold or scorching heat, akin to being inside a vast furnace. This isn't just a survival challenge. It's a question of humanity's very existence. Can we endure these harsh conditions to continue? Or will we be a fleeting ripple in the vast, indifferent cosmos? When everything seems hopeless, when the radiation from the red dwarf Proxima Centauri is attacking every cell in your body, when the fragile atmosphere of Proxima Centauri B is not enough to shield you from the harsh effects of space, there may be only one hope left to sustain life: the Terminator zone. But is this the last chance for humanity, or is it merely a temporary refuge, full of danger and waiting for inevitable failure? The Terminator Zone, a name that seems mysterious, is the region between the daylight and night sides of Proxima Centauri B, where the transition between light and darkness never truly ends. It is a twilight zone, neither fully day nor completely night. In this area, the temperature remains more stable than at the planet's extreme poles, where the sun shines eternally, or where darkness never relents. The deadly heat of the daylight side or the bone-chilling cold of the night side cannot penetrate the Terminator zone, making it the last possible place where life could thrive on this planet. So, can humanity establish a foothold in this area? Could the Terminator zone become our second home? Or is it just a temporary hiding spot amidst the inevitable cosmic disasters waiting to strike? Scientists argue that the Terminator zone may harbor water, the essential element for life. Water, the magical liquid without which life on Earth cannot exist, could be hidden in the planet's cracks, waiting to be discovered and utilized. But can life truly survive in a place so fraught with peril? Where water might only be an illusion, the air is scarce and radiation could strip away everything? Imagine that humanity has set foot on Proxima Centauri B, a distant planet in the Alpha Centauri star system. Imagine that we, fragile beings from Earth, have crossed this vast cosmic expanse to seek a new world. But can we truly survive in a completely alien environment where every familiar rule of life is upended? Can we navigate and endure in a space filled with dangers we've never even imagined? Proxima Centauri B is nothing like Earth. And the challenges begin the moment we arrive. One of the biggest hurdles is space itself, the space we've always taken for granted, now transformed into a maze of confusion. With no sunlight to guide us, no blue skies to orient us, we are lost in the shadow of a distant star. Proxima Centauri B orbits so close to its host star that it only receives a faint, dim light, like a tiny flicker in the vast, unending night. There are no familiar constellations, no guiding signals to lead us, only a thick, oppressive darkness. What will we do when we can't see anything but a foggy world before our eyes? However, an even greater danger lurks ahead. Ultraviolet radiation. Proxima Centauri, the red dwarf star that governs this planet, emits a kind of radiation far stronger and more dangerous than anything we experience on Earth. These ultraviolet rays are nothing like the sunlight we know without the protection of Earth's ozone layer. These rays would not only harm our health, but could also penetrate our cells, destroying DNA and exposing humans to the risks of mutations and cancer. Without special protective measures, the radiation from Proxima Centauri could quickly make any attempt at survival on Proxima Centauri B unsustainable. Proxima Centauri B, the closest planet to Earth, just 4 light-years away, has become the focal point in the search for extraterrestrial life. While it seems promising, we still don't know if the atmosphere of Proxima Centauri B can support life. Scientists typically use transit spectroscopy to study the atmospheres of exoplanets. However, for Proxima Centauri B, this method cannot be applied due to the planet's lack of conditions that would allow us to study its atmosphere through starlight. If the atmosphere of Proxima Centauri B is too thin to shield us from the dangerous radiation of Proxima Centauri, can we truly endure? A planet without this protective layer could be a barren wasteland, making settlement an insurmountable challenge. However, if Proxima Centauri B does have a sufficiently thick atmosphere and the right temperatures, it could support liquid water. Water, the essential ingredient for life, becomes our one glimmer of hope. If the conditions are right, water could exist somewhere on this planet, providing the foundation for life to flourish. But is that really possible, or is it just an illusion, a fleeting dream in the vastness of the infinite universe? Proxima Centauri B is a planet brimming with potential, yet it is far from without its dangers. Humanity would face serious challenges if we set foot there, from the intense radiation of Proxima Centauri to the fragile atmosphere that cannot protect us from the harsh elements. Life in such an environment would become an unceasing struggle, where every moment of existence is fraught with risk. Water, the essential building block of life, may exist, but it would be as fragile as a dream, barely graspable in the infinite expanse of space. Despite these formidable challenges, Proxima Centauri B remains a promising destination. This planet, with its hidden conditions, could hold tremendous opportunities for discoveries about life beyond Earth. While the obstacles are numerous, each step we take toward understanding this world brings us closer to the possibility of surviving in a completely alien environment. This universe is full of questions and opportunities. Proxima Centauri B, despite its dangers, is one of the great questions humanity cannot afford to ignore. Can we overcome the challenges to survive and thrive on a distant planet? Or will life there remain nothing more than a fleeting dream? The answer is within reach, in the first steps of our grand journey to explore the vast expanse of space. Since the Big Bang gave birth to the universe around 13.8 billion years ago, space has been expanding like a kite pulled taut by the wind, carrying hundreds of billions of galaxies drifting ever farther apart. Thanks to Hubble's law, we know the universe is expanding, and doing so at a staggering rate. In this vast cosmic canvas, our Earth, orbiting an ordinary star called the Sun, is but a tiny speck of dust floating in an endless ocean. Although astronomers have mapped out regions stretching 45 billion light-years, much of the universe remains a blank haze, unseen, unexplored, only dreamed of. Yet within this void, one star system draws particular attention. Alpha Centauri, the closest stellar system to Earth. Just 4.24 light-years away. Alpha Centauri is not a single star, but a triple star system. Two of them, Alpha Centauri A and Alpha Centauri B, are sun-like stars orbiting each other in a celestial dance lasting decades. The third star, Proxima Centauri, is smaller and dimmer, orbiting far from the pair, and it is actually the closest star to Earth. Proxima Centauri is the nearest star to our Sun, while Alpha Centauri A and B form a close binary pair. We are looking at a star system with a familiar structure, with planets located in the habitable zone, the ideal conditions for life to emerge. In 2016, humanity first detected signs of a planet quietly orbiting the star closest to us, Proxima Centauri. Since then, 3 exoplanets have been discovered: Proxima Centauri B, C, and D, dark gems hidden in the faint light of a red dwarf star. Proxima Centauri B is a strong candidate for life. It lies within the Goldilocks zone, the habitable region where temperatures are just right for liquid water to exist. With an orbital period of just 11.2 days. A year passes here in less than 2 Earth weeks. Its host star, Proxima Centauri, is a tempestuous red dwarf, frequently flaring with intense radiation and stellar winds up to 2,000 times stronger than those of the Sun. These magnetic storms could strip the planet's atmosphere, unless it's protected by a magnetic field as strong as Earth's. So what if life does exist on Proxima Centauri B, shielded beneath a magnetic barrier? Imagine a civilization thriving under dim red light, with organisms whose skin absorbs infrared light instead of white light. Their skin might be metallic black, red, capable of absorbing and converting infrared light, much like plants on Earth harness white light. Some creatures may be bioluminescent, forming networks of light in the darkness. Their eyes may be large and multi-layered, adapted for seeing in darkness and detecting radiation. Some may even perceive magnetic fields and wavelengths invisible to humans. Their bodies could contain biocrystals that reflect radiation, natural shields against stellar flares. They may communicate through emitted light, blinks, color changes, or intensity shifts corresponding to words, emotions, and tone. Their cities might be built deep underground or in massive caverns, using insulation and radiation-reflecting materials. On the surface, only observatories, power towers, or signal centers remain, shielded beneath giant magnetic domes that manage intense radiation. They may have engineered a planet-wide magnetosphere using giant magnetic cores, pulsing hearts of artificial field generation. Due to the dim light, they wouldn't rely on solar energy, but would harness power from gravitational shifts and cosmic radiation. Their spacecraft may not be metallic, but biomechanical life forms, capable of surviving space, self-repairing, and sensing space-time. Unlike Proxima B, Proxima C lies farther out, beyond the habitable zone, a giant planet, possibly icy or gaseous. Temperatures here are frigid, and the light is dim, like an eternal twilight. With only about a quarter of Earth's mass, Proxima D is likely a small rocky planet, orbiting very close to its star, perhaps too hot and harsh for life as we know it. But if beneath its barren surface lies a network of caves shielding it from radiation, could microbial or even intelligent life have evolved underground? In 2020, while humanity was grappling with the global COVID-19 pandemic, a mysterious signal from space quietly stirred the astronomical community. The signal, named BLC-1, was a radio wave sequence detected by the Parkes telescope in Australia, coming from the direction of Proxima Centauri, the red dwarf closest to Earth. It wasn't a gamma burst, X-ray, or typical radio noise, but a fixed, prolonged frequency. Steady and undrifting, unlike any natural signal. Its characteristics were chilling, stable, distinct, and seemingly intentional. Experts immediately ruled out satellites or human-made interference. It didn't match any known natural phenomena. Uniquely, BLC-1 did not repeat, as if it came just once, then went silent forever. But if it was random, why from Proxima Centauri? where habitable planets are under intense scientific scrutiny. If not by chance, could this be a signal from a distant intelligence? Testing whether we are listening? And if one day we reach Proxima Centauri, not by spacecraft, but through thought, data, and the gaze of our telescopes, then every thought, every question, every story like this will have been our first steps. We tell stories of unseen worlds not because we know what awaits, but because the desire to explore is instinctual. The universe is vast, cold, and indifferent, but maybe it isn't. Maybe, somewhere out there, a pair of eyes is also gazing back at us, wondering the same thing. Is anyone else out there? Giant ecological structures rise, protected by massive domes, where humanity steps into a space beyond the reach of imagination. After a long journey, humanity has found its new home under the light of Proxima. Welcome to Dawn Colony. Our space travel technology is not just a simple step forward, it's a breakthrough. Advanced spacecraft have carried us to a planet once only dreamed of. But the true wonder isn't just setting foot on Proxima B. It's the call from the universe, inviting us to uncover mysteries yet to be revealed. Proxima Centauri B, with its thin atmosphere and unpredictable temperatures, is a chaotic world. Yet it's also one where humanity can survive and regenerate under the cold, distant light of the red star. Dawn Colony is not merely a place to start over, it's a realm where everything can change. This is not a simple journey, but a turning point in our eternal quest, where humanity faces challenges that science has yet to explain. Can we master this world, or will we remain wanderers in a strange land, swept into a universe full of unanswered questions? Under the strange red light of Proxima Centauri, Proxima B appears as a distant alien world. To adapt to this unique environment, red light nurseries were developed, where specially chosen plants thrive under Proxima's spectral light. These areas are designed to harness the full potential of the red spectrum, ensuring crops grow vigorously, even though the light here is unlike anything we've encountered before. But it's not just the light that presents a danger. The ultraviolet radiation from the red dwarf star could be deadly, requiring humans to wear specialized protective suits to filter out these harmful rays. These suits allow them to survive in an environment that bears no resemblance to anything we've known on Earth. One of Proxima B's most peculiar features is its tidal locking, which means one side of the planet always faces Proxima, while the other remains in perpetual darkness. This creates a perpetual twilight zone, where temperatures remain temperate, a perfect setting for the Dawn colony to thrive. Beyond this twilight zone in the eternal darkness lies an uncharted realm of mysteries yet to be revealed. Perhaps eternal ice, underground reservoirs of water, or even geothermal life forms. These dark regions may become key areas for research and resource extraction, where geothermal energy and artificial light sustain life. Who knows what might lie hidden in that darkness? Could it be forms of life never imagined? Or small worlds filled with unimaginable surprises awaiting discovery? When humanity first set foot on Proxima Centauri B, we didn't just build a colony. We created a self-sustaining world, entirely different from anything on Earth. Under the ominous red light of the Proxima Centauri dwarf star, every structure faces an extreme challenge to protect against deadly radiation and create a safe space for life to flourish. To overcome this, the ecological shells were born self-sustaining cities, where buildings are not just shelters but living organisms. These massive structures are designed to withstand the radiation from Proxima, with layers of unique energy-absorbing materials and the ability to maintain stable temperatures throughout endless days. Closed-loop systems recycle water, air, and waste, creating a perfect cycle of life without waste. But the creativity doesn't stop there. The vertical gardens and biological farms are not mere crop fields. They are complete ecosystems designed to survive under Proxima's red light spectrum. These plants don't just provide food, they sustain life, creating an environment unlike anything we've seen on Earth. Covered by special glass domes, they harness energy from the red light. Transforming the gardens into vibrant, colorful spaces far beyond what humanity has ever known. Alongside this, groundbreaking energy technology powers the colony. Solar panels are not just designed to absorb sunlight, but are optimized for Proxima's red spectrum, providing energy and serving as shields against the weak light of the star. They not only help the colony sustain its operations, but also serve as shields, efficiently capturing energy from the star's faint light. But energy technology goes beyond just light beneath the planet's surface. Humanity taps into geothermal energy, using the planet's boundless heat to sustain life support systems. And even more mysteriously, technologies now harness the energy from Proxima's solar flares, transforming cosmic events once uncontrolled into powerful energy sources. Could this be the key to unlocking a new energy era? Moving across Proxima B presents another challenge. The dim light and harsh terrain make travel more difficult than ever before. Yet vehicles designed to traverse the planet's surface are equipped with unprecedented technology, allowing them to navigate smoothly in every condition, from bright red fields to deep, dark valleys. These vehicles adapt effortlessly to the constantly changing environment. To stay connected with Earth, an advanced laser communication system has been deployed, despite the vast distance and significant signal delay. What happens when a message from Earth takes months to reach us? Will we feel even more isolated in the vastness of space? Or will we forge a stronger connection than ever before with those who remain behind? As the red light from Proxima Centauri pours down onto Proxima B, the planet transforms into a world utterly unlike any we have ever known. If life exists here, it must have adapted in ways beyond our wildest imagination. Under the strange glow and intense radiation of the red dwarf star, life forms may have evolved entirely different colors and mechanisms, such as deep blacks, purples, or dark oranges, reflecting a perfect adaptation to this alien environment. Trees may no longer be green, instead absorbing red light to generate energy, utilizing a mechanism that science has yet to fully comprehend. Proxima B, a world shrouded in darkness, may harbor a mysterious ecosystem unlike anything we've seen or even dreamed of. But the greater question remains, could there be extraterrestrial life that is capable of communication? If native life exists, what would it look like? Could first contact occur safely, or would it unleash unforeseen dangers? Every decision to engage or avoid these life forms isn't just a scientific matter. It's an ethical one, as each choice could irrevocably alter the future of the colony. To create a suitable environment for humans, scientists have begun exploring biological terraforming, seeding Earth's life forms on Proxima B. They are experimenting with genetically modified microorganisms and plants designed to survive the harsh conditions of the planet. But can we truly modify the environment without upsetting the delicate balance of the planet's natural state? As the pioneers set foot on Dawn Colony, they didn't just build a place to live, they created an entirely new community. One founded on principles completely foreign to anything we've known. The social structure of this colony isn't based merely on Earth's values, but is being shaped by new principles where laws govern not just behavior but also protect life in a harsh, unforgiving world. Every decision, every action is tied to the survival of the community, where collaboration is essential to maintain life itself. The shared values of the colony's community are not solely survival, they embody a deep desire to reach beyond, to explore, and to build something greater. Beneath the red light of Proxima, they share one singular goal: to create a new, independent, and sustainable civilization. But a big question remains: will the residents of Proxima B continue to see Earth as home? Or will they begin to forge a new identity, a Proximan spirit, distinct, independent, and perhaps distant from the world they once knew? Will the solitude beneath Proxima's dim, red light make them feel adrift? Or will it foster a stronger sense of community than ever before? Questions about the meaning of life, about the purpose of living on a planet light years away from Earth will inevitably form, driving these new settlers to redefine what it means to be human. The future of Dawn Colony lies in the hands of those building it. Can they maintain long-term life, self-sufficiency, and independence from Earth? Under the red glow of Proxima's dwarf star, humanity will face harsh conditions. Yet it also opens the door to a vast opportunity, a world where anything is possible. The planet holds extraordinary ecosystems, advanced technologies, and untapped mysteries, making it the perfect ground for survival and growth. This vision is not just a product of imagination. Works of science fiction like 2001, A Space Odyssey, and The Expanse have already depicted life beyond Earth, yet Proxima B may be where this reality truly begins. Humanity's desire to reach beyond Earth is an eternal dream. Proxima B, despite its many trials, remains a beacon of hope in the vastness of the universe. Can we truly build a new future in a world so unfamiliar, under the red light of Proxima's distant glow? The questions are immense, but so too is the potential for discovery. The journey to Proxima B is not just about reaching another planet, it's about redefining what it means to be human, to explore, and to create a new chapter in the story of our species. Thanks to powerful telescopes like James Webb and Kepler, astronomers have discovered thousands of exoplanets, worlds orbiting distant stars. Many lie in the so-called habitable zone, where conditions might be just right for life. Dr. Lisa Kaltenegger of Cornell University believes that if Earth-like conditions exist elsewhere, then so might life, even if it's nothing like ours. And beyond science lies something more speculative, and perhaps even more profound. Some futurists and theoretical physicists imagine civilizations that have transcended matter itself. These beings might not need bodies, air, or machines. Instead, they could map the living architecture of the universe using sacred mathematical patterns, the golden ratio, cosmic spirals, the primal geometry of existence. The search for extraterrestrial life is not just a scientific pursuit. It's a quiet, persistent whisper from the human soul, asking the oldest question we know: are we truly alone? Long before rockets pierced the sky or satellites circled Earth, our ancestors looked up with a sacred sense of awe, as if the heavens weren't just filled with stars, but served as the ceiling of a vast, invisible spirit world. It was Galileo Galilei, with one of the first telescopes, who cracked open that celestial window. When he spotted dark patches on the moon's surface, he believed they were oceans, possibly teeming with life. It may have been a misinterpretation, but it marked a profound turning point. Science was stepping out of myth and into possibility. Then came Immanuel Kant, the great philosopher, who imagined a cosmos organized by levels of intelligence. In one of his more speculative hypotheses, he proposed that the farther a planet was from the Sun, the more intelligent its inhabitants would be. In his view, the Sun's intense light dulled thought, while distant, dimmer worlds might allow consciousness to flourish into something nearly divine. Today we know those early ideas were scientifically inaccurate. But the deeper question they sparked still burns. Is someone out there thinking about us? These ancient visions didn't just search for life, they searched for meaning. And from those first primitive lenses to the observatories of today, our journey has never been just about discovery, it's been about identity. We've walked on the moon, roved the red sands of Mars, sent probes to frozen moons and ancient asteroids. And yet, despite decades of exploration, we have not found a single living being in our solar system. At least, that's what the data tells us. But have we really seen everything there is to see? Or did something once exist only to vanish long before we arrived? One of the more controversial, yet strangely compelling, hypotheses suggests that the moon may have once hosted an ancient civilization. Those dark plains that Galileo mistook for lunar seas? Perhaps they are not oceans at all, but graveyards of a golden era lost to time. Some theorists believe this civilization could have collapsed in a catastrophic war or as the result of uncontrolled energy experiment. It's not entirely baseless. Plasma physicist Dr. John Brandenburg once cited evidence of unusual radioactive elements on Mars, pointing to the possibility of an ancient nuclear detonation of non-terrestrial origin. And then there's Jupiter, the gas giant with a magnetic field nearly 20,000 times stronger than Earth's. Astrophysicists like Dr. Kevin Baines at NASA have speculated that such an immense field could serve as a natural prison for high-energy life forms. Beings composed not of cells and carbon, but of plasma or electromagnetic force. We haven't found life in the solar system, but maybe we're not looking the right way. Maybe the truth isn't on the surface. It's buried deep, shielded from our instruments, hidden within the very structure of space itself. And while data may not yet reveal it, our imagination keeps knocking, asking to be let in. Thanks to advanced telescopes like Kepler, TESS, and especially the James Webb Space Telescope, we are now entering a golden age of astronomy. For the first time in human history, we're not just speculating about planets beyond our solar system, we're actually seeing them. Thousands of worlds have been confirmed, many similar in size to Earth, and a surprising number of them orbit within what scientists call the habitable zone, not too hot, not too cold, and potentially capable of supporting liquid water. Among the most intriguing candidates is TOI 715b. A rocky exoplanet located about 137 light-years from Earth. With a radius about 1.5 times larger than our own planet, and orbiting a cool red dwarf star, TOI 75b lies in an ideal range for habitability. It's currently one of the top targets in our search for signs of life. But here's the catch. The light we're seeing from TOI 715b today actually left the planet 137 years ago. In our search for life beyond Earth, humanity keeps returning to the same familiar checklist. Liquid water, biosignature gases, the Goldilocks zone, that sweet spot around a star, where temperatures are just right for life as we know it. We scan for traces of methane, oxygen, or signs of ancient microbes. As though the universe were obligated to follow the same biological script written here on Earth. But what if they, extraterrestrial beings, don't breathe air, don't need water, and don't even exist within the three-dimensional space we inhabit? What if life could exist without a body, without cells, without breath, yet still thrive? Scientists are starting to open up to these possibilities. As Dr. Sarah Seeger of MIT puts it, we may be missing the signals because we're only searching within our narrow band of understanding. One of the most intriguing clues in recent years has come from K2-18b, a planet roughly 120 light-years away. Observations by the James Webb Space Telescope detected water vapor in its atmosphere, alongside dimethyl sulfide, DMS, a compound that on Earth is produced only by marine organisms. This may be a faint greeting from a distant ocean, a place where mythic-like beings, perhaps the leviathans of ancient stories, silently drift beneath thick clouds and restless waves. Entire planets covered in water could host forms of life we've never imagined, creatures born of crushing pressure, eternal darkness, and heat from the planet's core, not sunlight. Some speculative biologists have called them biological leviathans, enormous lords of the deep, ancient in intellect and alien in every sense. And so our search for life is evolving into a deeper challenge, a race against the limits of our own imagination. We've launched spacecraft to the edge of our solar system, scanned thousands of distant planets with colossal telescopes. and decoded the faint glow of stars hundreds of light years away. Yet everything we know about the universe, about life, still amounts to little more than a speck of dust in an infinite desert. But humanity doesn't stop at the boundaries of the known. The search for extraterrestrial life is not just a scientific endeavor, it's a quiet yearning from the deepest part of who we are. In a cold and silent cosmos, where distances are measured in light years and silence can last millennia, we send out a call, not only to ask, is anyone out there, but to say, we are here, please hear us, to know, in some fundamental way, that we are not alone. Scientists like Carl Sagan once said, the universe would be a pretty big waste of space if it's just us. Will humanity be ready to face a consciousness far beyond ours? A truth that could shatter our religions, our beliefs, even our concept of what it means to be human? Maybe this journey isn't just about finding someone else. Maybe it's about rediscovering ourselves, reflected in the eyes of something completely unfamiliar. That horizon is expanding. And the real question is no longer, is there life out there? It's this, when that life answers, will we be ready to listen? Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.